Okay, at this point I assume you've read and worked the problem on your own. Part A should be pretty straightforward. I think it's an easy 2 points. Create the slope field. So you're just plugging in points to your slope. See, I end up getting 0 here. Let's see, plug in 1, 1. I'll get a slope of 1. Plug in 1, 0. Oh, they didn't ask me to. Don't fill those in. Okay, notice there's no point there. Okay, so let's see, at 1, negative 1. Let's see, plug in 1, I get 2, or excuse me, 3. So steeper. Okay. Let's see, at 0, negative 1, I'll get 1. Didn't have a point there, so don't fill that in. A lot of people do. Don't do it. Okay, so at 0, 1, I have a slope of negative 1. 0, 2, I have a slope of negative 2. Oops, it's a little too steep there. Okay, there we go. That was an easy 2 points right there. Okay, part B, find the second derivative in terms of x and y. So when I take this derivative, the second derivative there, I'm going to have 2 minus y prime, right? Implicit differentiation. But I need to be in terms of x and y. Well, y prime equals all this. I get 2 minus 2x plus y when I plug all of that in. Okay, that's a point for that. Now it says in quadrant 2, determine the concavity. Well, in quadrant 2 over here, x is negative, y is positive in quadrant 2. So if x is negative, you're going to have 2 minus a negative times a negative, which is positive, plus a positive. So 2 minus 2x plus y is always going to be positive. The second derivative is positive, therefore concave up. And that is my justification. I showed the second derivative is always positive. Part B is worth 2 points. 2 points total. Okay. Part C, does f of x have a particular, or let f of x be a particular solution? The next question 2, 3, does it have min, max, or neither there? Well, this one a lot of people overthink and do way too much work on. First of all, if it has a min or a max or saddle, the derivative is 0. So if I plug in the point 2, 3 into my derivative, right, dy dx, evaluated at 2, 3, I get 1, which is not 0. So the fact that the derivative is not 0 tells me there's not a min or max there. There's nothing. There's neither. So no min or max at 2. And showing that work is justifying. That was 2 points. Now part D is the weird one. Part D is the one a lot of people don't get many points on. It's a very strange question. Not many people did well on it. Okay, so remember we have dy dx. It's 2x minus y. And they're saying find the values of the constants m and b for which y equals mx plus b is a solution. Well, if it's a solution, I should be able to plug that in for y. I'm going to go ahead and distribute my negative. And then looking at that, remember derivative means slope? Well, what's the slope of this? The slope is m. So I plug that in for the derivative. Plugged in for y, plugged in the derivative. Going to get it all equal to 0. Now I'm going to go ahead and do some fancy factoring here. I'm just going to pull out an x there. So I have a coefficient. Okay, and here I'm just going to pull out a negative. It really doesn't matter. But looking at this, if I were comparing, I have a linear equation here. There's my mx plus b. Okay. And here I have 0. Well, the coefficient of x must match the coefficient of x over here, and there is no coefficient. So 2 minus m must be 0. So in other words, m must be 2. Same here, the constant must match the constant over here. So m plus b must be 0. So m must be negative b, or actually let's phrase that differently. B is negative m. Well, we already have m, so b is negative 2. Very confusing question there. It's worth 3 points. Not many people did a good job on that one.